Today we'll look at how to do virtual to physical address translation when your system supports a 4-level paging table. So as you can see in this diagram, so this is a 64-bit system. As you can see, the only the 0 to 47 bits are used. The upper few bits are reserved. Okay, so we'll see the translation process. So here we need two things. One is the CR3, which is the register which is having the entry to the page table entries, right? So once I have this, then I can do the translation. And the other thing I need is some address, right? So where I can try out this translation. So to do that, let's take a simple program. So I here have a C program where I'm printing some few values. So let's try to run the program. So now I can see it is printing some values. So let's take this virtual address of this global variable and let's try to see if we can convert this to a physical address and check its contents. Okay, so now let's go back to WinDBG. So I have enabled kernel mode for WinDBG. Okay, so the first thing is, since I'm going to use this value quite a bit, so let me create an alias because it's an hexadecimal value. So I'll create an alias for this address. Okay, and the next thing that I need is I need the process ID of this process so that I can get that CR3 register value, right? So let me go to process task manager. So here you can see the process ID is 5796. Okay, so but I need the value in hexadecimal. Okay, so this will print the value in hexadecimal. Then I can run the process command to 1684, right? And okay, so this will search for this process, and you can see that it is the process we are looking for. Okay, and let me just minimize these two windows. Okay, so now I got the directory base, right? So this is this base entry. So now what I need to do is like to traverse this table, I need to first get the 9 bits, right? 47 to 39. So what I can do is, so to access the value of virtual address, right? So this is how I can access the value. Beta. So this is how I can access the value. So what I will do is first I will say virtual address. Okay, I will take the value of virtual address and then I will have to check by so 39. Right, so I will write check by 39, which is hexadecimal 27. Okay, and I need to end it with an FF, which will give me the row-most 9 bits, right? And then I have to multiply by 8 because here the each entry is 8 bytes, right? So I have to go to the top set, so I have to multiply by 8, right? Then I need to okay, so here I have to do like 1, 2, 3, 4, 5, 6, 7, 13, 14, 15, 16. Okay. So here all these entries, right? The lowermost 12 bits are not used because they're used for other purposes, right? So they are not used for the address translation. So right. Okay, so I do this and then finally I can get the value. Okay, so after doing this, this is the value, right? So now I can see what is the value at that location, right? So now I got this value, right? So that is actually for this, right? So now it just now after this, it's like the same process continues, right? So I just have to just change these two values. So right, I just have to change this value, right? So first it was this value, and so like only that value will keep changing, and this offset will keep changing. Earlier it was 39, now it will be 30. So 30 is hexadecimal 1e, right? So okay, so then just get the value of that, right? And then this is actually, so I have to get this value, right? Mm, Here now the offset will be 21. So 21 will be, that is 150, right? Then I go and get the location. What is the value at that location? So I get this value. Now my offset is 12, right? So I try to by 12, which will be hexadecimal C. And this value is, so I just copy. Okay. And so lastly, right, so this value, so here there's no right shift. So I can just say 0, right? And here, as you can see, there's a slight difference. So till now we are using 9 bits. Now you will see that it's 12 bits. So I have to just change the mask to F, right? And let me just change the settings. Before that, I just have to get that notification. So, so this is the connection. And then zero, right? So this should be me the value. So let's try to print the value. So as you can see, the value here is 2D. Okay, so let's try to evaluate what that is in hexa. So this is 2D in hexa, which is decimal 45. Okay, so let's go back to that global variable. So as you can see, that value is 45. So that's how you can do this translation, right? From by traversing these tables. But if you don't want to do this elaborate process, there is a simpler way, right? Which is you just scroll up. So you have the base address, right? So one easy way is like there's a command called B2P, right? Which takes the virtual address, right? The direct base entry, and then whatever is the virtual address which you want to translate, right? So this one. So you can do it in one shot.